Okay, in this last bit, we're going to actually start from scratch and create an entire three-node scenario, hopefully without resorting to any pre-made configuration files. There's sort of a shell of one of these that's already built in. If you cd into .core, NASA, .core configs, .core/configs. NASA ion course, there's this directory here that's from scratch. And it's got some templates for building various config files. There's a little helper file here to sort of expand those into 3 nodes worth of templates. And hiding down here under the working directory is a completed version that actually works. But we're going to go ahead and try to build that up by hand. I've got the slides for this open on another window, so I'm just going to walk through here, sort of doing the steps, and you can follow along in the slides, or if you can do this sort of with me on your own if you've got a dev kit up and running and want to play with it. So we're going to build a 3-node network from scratch. And that's going to cause us to have to generate all the config files and then also to start up ION on the nodes, since we're not going to be using sort of the dev kit's built-in start scripts. So we can start from here, from the ION course, the from scratch directory, and let's start up a core GUI. And so here's a nice blank canvas, and we can take some nodes from here. And let's just take these normal routers and drop down a couple of nodes onto the canvas like that. And then we'll connect them together. And for this, we're just going to use wired connections. So I don't want to get into mobility and wireless networks at the moment. So we click the link tool, and you can just click and drag from node 1 to node 2, and then from node 2 to node 3. And it'll generate us some IP addresses automatically. And we can start from that. So for each one of these nodes, we're going to need an Inrc file, an ion config file, a BPRC file, an IPNRC file. I'm going to suggest that we not use LTP. We'll just stick with either TCP or UDP convergence layers. And we'll probably want to have a blank ion secrc file. And we can skip using aggregate custody signaling for now as well. So what we can do here now in this from scratch directory, we've got basic templates for BPRC and contacts, etc. I'm just going to do /expand templates.sh. Oh, tempit. We will fix the spelling error in there. I'll get that done before I cut the next release of this. Expand templates.sh. There. So now what that's done is it's gone through, and now I have in here an n1.ppnrc and n1.inrc and etc. for n1, and here's the n2 and n3. So I've got a bunch of configuration files for each one of the nodes that we can now go through and tailor. Vim n*.inrc, maybe. Okay, so here's sort of the template for an INRC file. We've got a start command. We need a node, and then we're going to have an ion config file to go with that. So this first one is going to be node 1, and it's going to be node 1.ionconfig. Next would have been my friend. Next, yeah. No, this is node 2's INRC file. So we're going to make that, and startup 2 in n2.inrc. I'm going to write that. I'm going to go next. And then I'm going to take n3 and n3's ion config, write that out, and quit. So that gives us the basic Inrc files for the various nodes. And then we can move on to the ion config. So vim and star.ion config. So here we're going to leave the memory key alone. SDR name ion is fine. We can leave all these things alone. Let's note that the path name here is set to var ion because that's going to be important. And we're here. These are the config flags that control how what goes on with the SDR, like whether or not it's kept in DRAM or in file or reversible. Let's go ahead and set the flags to 15 so that we're going to do bounded, reversible, and file-backed memory. So this is something that's closer maybe to what you, well, at least the reversible and file-backed memory configuration is something that you might want to use for flight. And the SDR bounded, probably not something you might want to use in flight. SDR bounded, if you'll recall, is checking to make sure that you don't exceed bounds when using the SDR. It's doing some boundary checking. But we'll write that out, and that's node 1. And we'll set the same things for nodes 2 and node 3. Oops. And here's node 3's ion config. And we're done. Now we need to set up each node's BPRC files. So vim and star.bprc. So here's node 1's BPRC file. So here we're going to get into what protocols are we going to be using, what schemes, what endpoints. We're going to need an initialization command, which isn't in the template, so let's give it a 1 up at the top. We're going to need, let's see, is there a scheme in here? No. So we're going to need a scheme, add scheme called IPN. It's going to use the IPN forwarder, so the thing that understands these IPN scheme names like IPN :x.y and IPN admin endpoint. So we'll give it that. We probably ought to give it some endpoints, otherwise we're going to have a hard time just getting things started. IPN, this is node 1, so let's do 1.1x, and I'm just going to make several 2, 3, 4, and 5, so that we've got a couple of spares for doing what we want with. UDP seems like good enough. Let's use UDP for communication. We've got an induct for UDP already. I added that into the template that way because this is listening on INAT or any, and again, I typically will put a UDP convergence layer for loopback. Now here's a bit that's changed since I made the templates. This the UDP CLO wants to take a default round trip time as an argument, and the config files that I have here are the old version where it didn't take that. So here we've got an outduct from UDP now that's headed to so that it can talk to itself. We've got watch characters turned on. We're going to read IPN admin n1.ipnrc. So when we go build the ipnrc file, we could tell it how to do that and then start. So the only thing really that we're missing now, this is configuring node 1. move these folks a little further apart. So we've got an out duct for talking to ourselves. We don't have an out duct for talking to node 2. So let's go ahead and say that 10.002 is going to be node 2. And I'm just going to copy that out duct line and say that it needs to have 10.002. And again, UDP CLO and just give it a 2-second round trip time. I'm going to write that out. And now I'm going to move on to node 2. And again, I'm going to need an initialization command up here. I'm going to need to add a scheme for IPN, the IPN forwarder and IPN admin endpoint. And I'm going to need several endpoints again. Add endpoint IPN colon 2.1. Oops. And let's go ahead and add that with discard for if a bundle comes in and we don't have an application that's sitting there waiting for it. And go ahead and give us some other endpoints that we can use just for testing. Okay, so that should do that. We've got UDP. Again, we've got a UDP link to loopback so that we can talk to ourselves. We're going to run IPN admin n2.ipnrc and get things started. Now here, we're configuring node 2. So he's got 2 neighbors, node 1 and node 3. So we're going to need 2 other UDP out ducts, one for 10.001 and one for 10.012. So let's go ahead and get this. Oops, maybe before we copy that line, again, we need to add the round trip time onto the UDP CLO command, and then, what did I say, 10.001, 10.001, and then probably 10.012, right, 10.012. And then we go all the way down and we start, okay. So that gives us node 2 with 2 neighbors, node 1 and node 3, so I can get to those. Oops, next. Node 3, again, I need an initialization command. I'm going to add a scheme for IPN, IPN forwarder, IPN admin endpoint. I'm going to need some endpoints. And this was node 3. So 3.1, 2, 3, 4, 5. UDP is a protocol. It's got a UDP induct. Here's an out duct that we're going to set correctly. And this is again node 3. So he's got one other neighbor, node 2, at 10.011. So let's go ahead and tell him that he can get to 10.011. And we're going to run node 3, oops, node 3's IPNRC and start everybody up. So that should do us for BPRC files. Now we need the IPNRC files. If you remember, the IPNRC files define how to get to your immediate neighbors, so that's going to be important. n*.ipnrc. So here's node 1, and it has a plan to get to node 1 via loopback, so that seems right. But we need to give it a plan to get to node 2. And again, here's node 1, here's node 2, 10.002 is his address. So let's go up here, 10.002. I think that'll do it. Here, tricky bit here, this one is still set for 1. So his plan really needs to be to get to himself via loopback. And then he needs to be able to, node 2 needs to be able to get to both nodes 1 and node 3. So we're going to need something for 1 and something for 3. Node 1 is going to be 10.001, and node 3 is going to be 10.0.1.2. So that should get us loop back to ourselves and 1 and 3. And node 3, again, really you can't get to 1 by loop back, but you can get to 3. And 3 also needs to get to 2, and 2 is at 10.0.1.1. So here's node 3. His interface on the interface that he was going to talk to on node 2 is 10.0.1.1. So hopefully that'll do us there. This should be fine for LTPRC files, right? We can define a max number of sessions and a max block size. We can go ahead and let watch characters happen, but we're not going to have any LTP convergence layers. So actually, if I do that, then this should be fine for all of the nodes. And similarly for the cat n1.ion sekrc. So this is fine. This is just an empty ion sekrc file with an initialization command. And we need that because it'll quiet down, it'll keep ion from throwing a bunch of warnings into the ion.log file. We need some contacts. Let's see, do I have a contacts file? Vim contacts.nrc. And there's a bunch of things already defined. Okay, so here again, we're going to define the range, which is the light distance between node 1 and 1. So to talk to itself, go ahead and tell ion that it's a second. That's fine. This contact is from 0 to 4 million seconds. So this is again over loopback, so node 1 can talk to node 1 at some particular rate. We've got a contact range and contacts for node 2 and node 3. And then we need to go through and set up ranges and contacts for 1 to 2 and 2 to 3. And here, this is 1 to 2 and 2 to 1. So these are node 1 and node 2 here. These two on the left-hand branch are constantly connected. And then in here I went in and stitched up a couple of different contacts on the 2 to 3 link. So the ranges for 2 to 3 are constant. It's always, they're always 1 light second apart. But we have a couple of different contacts. So 2 to 2 can talk to 3 for 60 seconds, then off for 30, on for 60, off for 30, on for 60, and so on. 2 to 3, 3 to 2, 2 to 3, 3 to 2, 2 to 3, 3 to 2. It's easy to get these messed up, but that looks like it ought to be right. So that's pretty much it for the configs themselves. But remember when we looked at the ion config file. So if I cat n1.ion config, remember we put the SDR is file backed, and it's going to hide here under var ion. So we don't want all 3 of these nodes writing to the same var ion directory, which they would do if we don't do something in core to tell core that we want those to be special and separate. So again, we'll right click on this node, we'll go down to services, and we'll go into the user defined. So here, if you simply click here in this part, it will turn on the user defined service, but it will be completely blank, so that's not very useful. If you click over here in this little file icon with a wrench on it, then you get the opportunity to go in and change things. And what we want to do is add directories in var ion for each one of the nodes so that they each get their own var ion directory, so that when they write SDR journals down in there, everything, they'll be separate and not the same. So right now it shows as just slash. That's a little bit misleading. It's not that everybody gets their own root directory, But if you click here, the easiest thing, if you don't necessarily have a var ion directory, is in the selection dialog box. Just type var ion, OK, OK. And now we've got a var ion directory that's going to be private to this node. I'm going to say apply and apply. I'm going to do the same thing on nodes 2 and node 3. Directories with these, var ion. Oops, not services. Not configure. Hello. Oh, right. Yes, services, user-defined service, directory here, var ion, apply, apply. All right. With that, we should have everything set up right. And now, what shall we do? I'm going to go ahead and say save this under ion course. I'm going to put it in the from scratch directory. Try one. Save. And I'm doing that because if something goes horribly wrong and I accidentally close out of this window, I don't want to have to go through and reconfigure all the user-defined services again. So now what we're going to do is we're going to start this up. It's going to start up 3 nodes, and they're going to be essentially blank, right? They'll be running. Let's see what other services are defined on here. So they're going to come up by default running OSPF and having IP forwarding turned on. We can go ahead and turn that off. For us, it doesn't matter. If we wanted to do actual IP routing and multi-hop IP routing across these nodes, we would want these turned on. But I'm going to go ahead and turn them off because it's just going to simplify things a little bit when we do start it up. So we start these up, and now Core has given us 3 little bitty virtual machines. If I double click on N1, we can look here. We don't have very much. We don't have as much stuff as we get when we start the regular the other scenarios that are in the dev kit, because none of that extra machinery for copying files and doing all that stuff is happening. Really, what we see here, and I'll do an ls-f. This is a var ion, a var log, and a var run, and this is the private var ion directory. So we can look at that. It doesn't. I guess it doesn't show up when you do a df as mounted. But this is the directory where the private version of var ion for this node is going to live. So we've got that, and we can do a PS. And here I'm going to export term. I need to figure out how to sort that out. So here we do a PSAUX, and by gosh, there's almost nothing running on this node. There's this vnode-d, there's bash, which is this shell that I'm running, and there's ps, which is the command we just did. So there's no ion, there's no nothing, almost nothing running on this node. So now we're going to need to actually invoke ion here. And what I'm going to do is on each one of these things by hand, I'm just going to copy all the config files from that from scratch directory down here onto the node, and then we can start it from there. So I'm going to do a cp ~/.core configs. Oh, right. ~core/.core configs. It didn't like the tilde because it went back to root. NASA ion course from scratch. This is what node 1 N1 star, And we also need, I'm just going to take everything. Well, we need contacts, and I suspect we're going to want whatever this script is. Looking. Nope, I think that's it. What's down in working? Oops. I think what I'm looking for here is, I'm pretty sure there's a version of an ion start script. This ion course. Just expand templates. Oops. Okay, well, we'll just do them all by hand then. That's fine. So where are we? This is N1. We've got a bunch of N1s, configs. So let's go ahead and copy configs down into N2 and N3. So I'm double click on N2. I'm going to double click on N3. That's going to give me two other tabs up here. I'm just going to do a cp tilde core / .core configs. Out of the ion course from scratch, yes. N2 star to here. I'm also going to take the contacts. And was there something else I needed out of here? No. I think that'll do it. We'll go over here to, this is node 3. From scratch, N3 star to here. And let's also take the contacts file. Okay. So now I'm going to go, I'm going to go back over here to node 1. And again, nothing running. So let's go ahead and start everything up by hand. So I'm going to do ion admin n1.ionrc. And that looks like it didn't complain too much. Now, in particular, I've got an ion.log file. So at least, something happened. Let's see if ion.log is complaining about anything. No, seems all right. I'm going to do ion admin contacts.ionrc. You can also look at ion.log. Okay, fine, fair enough. Ion secadmin n1.ionsecrc. Okay. bpadmin n1.bprc. Okay, so let's see what's running now. We've got our RFX clock. We've got a UDP CLI. We've got 2 UDP CLO processes that are running. Let's see if we do bpadmin. We can look here, L outduct. Fine, looks good. bping, IPN:1.3 to IPN:1.1. Okay, something's not right. BP stats, tail ion.log. So what's happening? We're getting ABCs, so that's bundles getting queued outbound. Oh, I know what's wrong. So things are going out. We're getting Y's and Z's, so bundles are getting received, but we're not getting any answers. And the deal there is, again, PSAUXWW, if you look around, we're not running a BP echo process. So we can